Hello, this is going to be a very short video on how to simplify radicals, especially radicals that involve variables, and they involve radicals that are going to a higher order. They have a higher index than what we're typically accustomed to. So this is going to be kind of an introduction to cube roots, to the fourth power roots and fifth power roots on simplifying. So at the beginning of the semester, we had the square root of 24, and we were asked to reduce it. So what we did was we found two factors of 24. In this case, I'm going to select 4 and 6. And we said, well, 24, it's still the same thing because 4 times 6 is still 24. And we said, well, 4 reduces to 2 times 2. And 6 reduces to 2 times 3. However, since we had a pair of 2's, we rewrote the equation as 2 squared times 2 times 3. We said, well, the square and square root will cancel out over the 2, but not over the final two terms, which would simplify back to 6. This is not unlike a process that we're going to be using today to work with higher order radicals. To work with higher order radicals, we're primarily going to be using the chart that we created in class the other day. The first thing that we want to really pay attention to is that index. So the value that's sitting over here on the ledge on the radical. The radical is all, so it could be an implied 2 from a square root. It could be a cube root. It could be a fourth power root. It could be a fifth power root, and I think there's even a sixth power root on here somewhere. And what we'll be doing is we're going to be looking for the largest value that's going to be divided evenly into our actual problem. Now, when we're doing that, we're going to primarily be starting with, say, either the x squared column or the x cubed column or the x to the fourth, just depending whatever n is. And then we're going to simplify it much like we did at the beginning of the semester. What's going to be different with variables? Well, we still are going to separate the variable from the number. And when we separate the variable from the number, we're going to start by rewriting it as a fraction, as a rational exponent, just like we did the other day in class. And what we're going to do with that is we're going to change that fraction to a mixed number if it can. And so like 1.5 or whatever it may be. And the whole numbers are going to be real nice because those have been kind of simplified out for us already. The fractions are going to return back to being an exponent at the end, or going back to becoming a radical at the end. So let's take a look at the problem we've already done, the square root of 24. We're going to try simplifying it this new way. So what we're going to start by looking at is we're going to start by, looking at the index. So this is one where the index was missing, and like we discussed, when the index is missing, it's an implied that it's a square root, and a square corresponds to a second power. So we're going to be using an index of 2. Now what we're going to be doing is we're going to look at our x squared column because we're trying to figure out what is the largest number under that is a perfect square that divides into 24. So we don't have very many choices this time. We've got 1, 4, 9, 16, and 25. I could have stopped maybe a little bit earlier, but I know 24 is not going to divide by 25. I know 24 is not going to divide by 16. The largest number I know that divides into 24 out of these choices is 4. So I'm going to simplify my radical to the square root of 4 times 6, because I know 4 times 6 is 24. And we know that the square root of 4 would tell us that that is just 2. The square root of 6 is not in our perfect square column, and so that has to stay under the radical, and that's going to be our solution. Now when we look at question number 3, on number 3, we're dealing with a cube root of 162. So what that means we're going to look at is our index of cubed, and we're going to look at the x cubed column on our chart. And so we're going to just kind of look at the list on that. We've got 1, 8, 27, 64, and 125. Out of those, the only one that divides evenly into 162 would be 27. And I know 27 times 6 would be 162. And so when we're trying to take the cube root of 27 times 6, we know the cube root of 27 would just simply be 3. Well, 6 is not in our cube category, so that's just going to have to say 3 times the cube root of 6, and there's our answer. Okay, so I'm looking at question number 5 on the homework now. This time we've got the 4th root of 128 into the 8th. Now, just like earlier this semester, we're going to separate the number from the variable. So I'm going to be looking at the 4th root of 128 and the 4th root of n to the 8th power. So I'm going to start with the whole number, which I know the index on this problem this time is 4. So I'm looking at my x to the 4th column on our table. And we've got 1, 16, 81, 256. I know 128 is not going to divide by 256, so I'm not going to go any farther down than that. The largest value that we know of that goes into 128 out of these options would be 16. So we're going to rewrite this problem as 16 times 8, because 16 times 8 is 128. And when we take the 4th root of 16, we know that corresponds to a 2, but we cannot take the 4th root of 8, so we've just got 2 times the 4th root of 8. Now when we get over to the 4th root of n to the 8th power, we're going to start by writing that as a fraction. So we've got n to the 8 divided by 4. Then we're going to just kind of reduce our fraction. So 8 divided by 4 would just simply be squared, or 2. 8 divided by 4 would be 2, and so we have n squared. Now when we take the answer from the numbers and the answer from the letters, we're going to put it together. You notice on the right side there was no fraction left when we divided it, so there's nothing under the radical from the variables. And it's just going to simply be 2 n squared times the 4th root of 8. Now when we go on to question number 7, this time we're dealing with a very large root. We're dealing with a 5th root of 224, x to the 7th, y to the 7th. So the first thing that kind of stands out very plain to me is we've got an x to the 7th and we have a y to the 7th. We're dealing with variables. They're going to end up simplifying the same way because it's the same setup. So I'm not going to be doing a whole lot of focus on that. So I'm going to start by separating all 3 parts. We got the 5th root of 224. We have the 5th root of x to the 7th. We have the 5th root of y to the 7th. So I'm going to be looking at our index. Our index at this time is 5. So we're going to look at our x to the 5th column. We've got 1, 32, 243. We don't have a whole lot of choices here. I'm willing to bet the only number that 224 is going to divide by out of this list is going to be 32. And when we check it, 224 does divide by 32, and it's 32 times 7. So we're going to replace this problem with the 5th root of 32 times 7. We know the 5th root of 32 is 2, but 7 does not have a perfect 5th root, so we're just going to leave that 5th root as 7. Okay, so now when we look at the variables this time, let's say we look at x to the 5th root of x to the 7th. We're going to start by changing it to a fraction like we did the other day. So we've got x to the 7 divided by 5. And when we look at that, okay, so we're looking at 7 over 5. I'm going to change that to a mixed number. So that would be 1 and 2/5 left over. So I've got 1 and 2/5. So we've got 7 over 5 reduced to 1 and 2/5. And so what that means we're going to change this to is we're going to change this to x to the 1st and x to the 2/5. Now, I still have a fraction left over with that x and 2/5, so I'm going to change that back to a radical. So that would be the 5th root of x squared. And then we just have the plain x from the whole number. And then the nice thing about the 5th root of y to the 7th is it's going to simplify pretty much the exact same way. Y times the 5th root of y to the 2nd power. When we take all 3 parts and put them together, we have 2x, y, and then we have the 5th root of 7x squared y squared. And that would be our answer. Okay, so I'm going to be looking at the final 2 problems, or these are going to be the final 2 problems that I'm going to be working out from the assignment. So number 9, we have the square root of 392x squared. Now, like we know, hold on. Okay, so on number 9, we've got 392x squared. Now this time, since we do not see an index that's listed, remember that's implying that it's an index of 2. And so we're looking at the square root of 392x squared. So we're going to separate the number from the variable. So we have the square root of x squared, and we have the square root of 392. So I'm going to start with the number. With the number, I know since it's a squared, I'm going to be looking at my squared list. So we've got 1, 4, 9, 16, 25, 36. We've got 64, 81. We have 100. I skipped 49 for some reason. We've got 121, 144, 169. And then we have 196, 225. And I'm going to kind of stop there because we're at the bottom of our list. Now when I go to work this one out and I start checking, I'm always going to be looking for the largest number. So I'm actually going to start down here at the bottom. I know 392 does not divide by 225, but it does divide by 196. And so we're going to change this to 196 times 2. 196 times 2 gives us 392. Now when we square root that, the square root of 196 would leave us with 14, and then we've got the square root of 2. Now when we come over here to the square root of x squared, we've got the 2 divided by 2. When we change it back to a fraction, and 2 divided by 2 simplifies to just 1, or just regular old x. So in this case, when we put the 2 together, we have 14x times the square root of 2. Now the final one I'm going to do is number 11. We've got the fourth root of 405x cubed y squared. So again, we're going to take all three parts. We're going to separate all three of them. So we're going to have the fourth root of 405. We have the fourth root of x cubed. And we also have the fourth root of y squared. So when we start with the 405, we are going to be looking for the fourth index, so the fourth power numbers. With the fourth power numbers, we can see, well, that's 1, 16, and then we have 3 to the fourth power would be 81, and then 5 to the fourth power is going to be, or 4 to the fourth power is going to be 256. And that's already more than half, so I'm going to kind of stop there. Then know the largest number out of these four that actually divides into 405 is 81. So we have 81, and that would be 81 times 5. So we take the fourth root of 81, and the fourth root of 81 would leave us with 3. And then we have times the fourth root of 5. Now with the fourth root of x cubed, that would be equal to x to the 3/4 power. But that doesn't simplify. There's nothing I can really take out of that. So I'm just going to change that back to a radical of fourth root of x cubed. With the fourth root of y squared, when we change that to a fraction, we have y to the 2/4 power. 2 over 4 does reduce, and that reduces to y to the 1/2. Okay, which would otherwise just be the square root of y. So when we put all three parts together, we end up with 3 times the fourth root of 5 x cubed, and then times the square root of y. But typically, you see how we've got two different kinds of square roots? Since we've got two different kinds of square roots, particularly with a square root and a fourth power root, what that's going to tell us is we don't like to have multiple roots in a problem, so it's going to, since the y is what's different, we probably want to change that and just leave it as it was. So we're going to change that back to y squared, just so it's only one root. And so it's still y to the 2/4, or y to the 1/2, but so we don't have to write a whole bunch of square roots, we're going to be leaving it like that. Good luck. If you have any questions, please make sure to contact me today.